Hi guys and girls, a video here on how to work out the nth term for a quadratic sequence. The two main things that you kind of need to ask yourself is how do you know it's a quadratic sequence and how many n squareds do you actually need. The first bit's quite easy to work out, so the how do you know it's a quadratic sequence. Well, normally on a sequence, let me grab my pen, let's go purple. Normally, we would have the same number being added or subtracted from the sequence each time. But on this type of sequence, well, we've added 3, then we've added 5, then we've added 7. So that's not normal. However, if we look at those differences, they go up by 2. This is called your second difference. So the how do you know is second differences are the same. Oh my word, I'm trying to mix up my words. Are the same. There we go. And similarly, if it was the third difference that was the same, you'd have cubic sequence and all that, but you don't need to worry about that. We're just concentrating on second differences for now. The second key piece of information is how many n squareds do you have in your sequence. Well, the number of x squareds, n squareds, whatever you want to call it, is half the second difference. So in this case, because the second difference is 2, we just have one lot of the n squareds. So if we now look at what n squared looks like, so that sequence is 1, 4, 9, 16, dot, 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 dot. The square numbers, we should know all that, that's fine. But they're not the same as the green numbers. So I need to adjust them slightly. So to get from, let's go more colours, this is going to be a very colourful video. To get from these numbers to these numbers, what do I need to do? Well, I need to add 2 to that one, add 2, add 2, add 2. Right, so all of the green numbers are the n squared numbers, add 2. That is your nth term sequence. Right, so the n squared numbers have to be adjusted to make the green numbers by adding 2 to each one. Right, I'm going to do another example. Let's go back to my green pen. So if I were to do -3, 0, 5, 12 and work out my differences, so that's gone up by 3. That's gone up by 5, that's gone up by 7. So the first differences are not the same. The second differences are the same. That's how I know it's quadratic. Half of that number is how many n squareds I have. So I just have n squared, 1 n squared. And that goes 1, 4, 9, 16, dot, 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 dot. They are not the right numbers. So I need to work out how to adjust them to be the correct numbers. So to get from those numbers to those numbers, so 1, that means take away 4. 4, I have to take away 4. These are all going to be take away 4. So my nth term formula is the n squared numbers take away 4. Right. But what if it's not just n squared? So far, both of my examples have just said, okay, we've got 1 n squared. So let's see one where it's not. So let's go with 1, 7, 17, 31. So still the same thing. Work out the differences. So that's gone up by 5. That's gone up by 10. That's gone... It's not gone up by 5, silly woman, it's gone up by 6. That's gone up by 14. So the first differences are not the same, but the second differences are the same. And this number, half of that number, is how many n squareds I have. So I have 2 n squareds. So if we look and see if those are the correct numbers. So the n squared numbers get multiplied by 2. That's all that means. So it was 1, 4, 9, 16. We're just going to double those. So double 1 is 2. Double 4 is 8. Double 9 is 18. Double 16 is 32. As you can see, your green numbers are not the same as your orange numbers, so you need to adjust them. So I need to get take away 1, take away 1, take away 1, take away 1. They're all take away 1. So my nth term this time is 2n squared take away 1. Hopefully you're still following along with me. I've got a couple more examples for you. The next ones are going to be ones where, well, what if it's not just simply add something or take something to adjust the numbers? What if there's something more going on? So, next one. We are doing 1, 6, 13, 22, ... The process still starts the same. Work out the differences. So that's gone up by 5. That's gone up by 7. That's gone up by 9. So my differences, second differences, are plus 2. How many n squareds have I got? I've got 1 n squared, which are 1, 4, 9, 16. Clearly not the right numbers, so I need to do my adjustments. So to get from those numbers to those numbers, well, I don't need to do anything to the first one. I need to add 2 to the second, add 4, add 6. Add 0, add 2, add 4. Hang on a minute. If I take them off, slide that out of the way for a sec, that's just another sequence. That is just a normal sequence. So if I put that to you and said, right, just do the nth term of that. So we look at the first difference. So that's gone up by 2. That's gone up by 2. So this is a normal sequence. That tells me that I've got 2n. But I don't want to start with 2, I want to start with 0, so I've got to take away 2. The same way you would do a normal linear sequence. So we know we had the orange bit. The orange bit was n squared. And we've got this new pink bit here as well, so we've got 2n minus 2 as well. That is our nth term. I'm going to run through that again. Hopefully you're happy up to the adjustments. So now we just look at the adjustments and we find the nth term for that. So we ignore everything that's come before it and just treat it the same way we would do any other sequence. So these are all add 2's. Which tells you you've got 2n in your sequence. But you don't want to start with a 2, you want to start with a 0, so you take off 2. And then you put it all together. So you've got n squared there, and 2n minus 2 to give you your full sequence. Okay, last example, it's going to be another one similar to that. So we're going to go green again. We are going 1, 3, 9, 17. First differences is 2, 6, 8. Not the same. Second differences 4, 4 are the same. How many n squareds do I have? I have 2 n squareds. So that is the n squared numbers and then double them. So 2 and double 4 is 8, double 9 is 18, double 16 is 32. They are not the right numbers, so we have to do our adjustments. So to get from there to there, I've got to take away 1. I've got to take away 5. I've got to take away 9. And I've got to take away... something doesn't feel right there. Oh no, it is right. 13. Hang on a minute. I've totally read my notes wrong. This should have been a 19. Because of course, 6 plus 4 is not 8 at all, is it? It hasn't changed anything. Oopsie, there we go. Okay, the calculation, everything that I've done so far is perfectly correct. It's just that last number wasn't quite right. But the process, like I say, is correct. Give me my colours, please. That should have been 10. Now that makes sense, because 6 plus 4 is 10. Anyway. Yes. Sorry, momentary sidetrack. Hopefully that hasn't thrown anyone off. So the adjustments, if we just look at the adjustments, that is a linear sequence because each one is going down by 4 each time. So you just do bog standard normal finding nth term. So the fact that it goes down by 4 each time tells you you've got negative 4n. But you don't want to start with a negative 4, you want to start with a negative 1. So to do that, you have to add 3. So all in all, you've got, come on, give me my pens again. There we go. All in all, what haven't I done? Red. You've got 2n squared there. And you've got minus 4n plus 3. That is your nth term. Hopefully that all made sense. Let me know if not. Bye.